Now that you've been introduced to how electronegativity can be used to determine whether electrons between two elements are transferred or whether they are shared, whether it be equally or unequally, this video will expand upon that and give us a very predictable and systematic way to determine whether two elements form an ionic, polar covalent, or nonpolar covalent bond. Now, to do that, we can operate from the starting point that was used in Science 10 by simply stating that an ionic bond occurs between two elements where one of them is a metal and the other one of them is a nonmetal. Alternatively, sometimes ionic compounds that don't have metals have some sort of polyatomic ion in the structure. Now, therefore, any substance that is covalently bonded will contain no metal and no polyatomic ion of any kind. Now, following this definition, HF, hydrogen fluoride, or hydrofluoric acid as it takes place in water, should therefore be automatically considered a covalent bond. Now, if we were to use the electronegativity difference on its own, typically anything with an electronegativity difference that is less than 0.5 is considered nonpolar covalent, meaning that the electrons are shared basically equally between the two substances. Conversely, any pair of elements that have an electronegativity difference that is greater than 1.7 would therefore be considered an ionic bond, and therefore anything in this range, less than 1.7 but greater than 1.5, would be considered polar covalent, in that the electrons are not transferred, they are still shared, but they are shared unequally. So let's see whether hydrogen fluoride follows this requirement here. Firstly, we can identify the electronegativity constants. Hydrogen is 2.2, and fluorine, the highest electronegativity on the periodic table, is 4.0. So if we do a quick delta En calculation, 4.0 minus 2.2 comes out to being 1.8, which, following this generalization that we see here, this technically means that hydrogen fluoride is an ionically bonded. The problem is hydrogen fluoride does not have a metal and does not have a polyatomic ion. So how can we rationalize this even though HF does not fulfill the Science 10 requirements of an ionic compound? Well, the tool that allows us to most accurately represent whether a substance contains an ionic, polar covalent, or nonpolar covalent is a tool that we call the triangle of bonding, in which it measures two variables, one of which is the electronegativity difference. So delta En is measured on the y-axis of this triangle of bonding here. The other number that we can calculate is the average En, or for the people with a good mathematics background, a better word to describe this is the mean, where we take the sum of the electronegativity constants, which is 2.2 for hydrogen and 4.0 for fluorine, and add them together, which is a total of 6.2. And because there were two different electronegativity values, all we need to do is divide this number in half, so the average electronegativity for H and F is going to be 3.1. Now, because this triangle of bonding exists on a graph, we can plot the difference in electronegativity as being 1.8 approximately here. We're just ballparking, but you can get the general idea. And then the average electronegativity of 3.1 is going to fall right about here, closer to 3.0 than 3.5. And if we find the intersection point of these two numbers, we can see that this falls clearly in the part of the triangle of bonding that labels this as a polar covalent bond. So what this means, using what the electronegativity showed us yesterday, because the electronegativity of fluorine is significantly greater but not enough for a full electron transfer, the electrons in the bond between hydrogen and fluorine are shared, but much more unequally than in a true nonpolar covalent bond. So because of the fact that the electrons in this bond are much closer to fluorine than hydrogen, that gives fluorine a very, very strong but still partial negative pole, and gives hydrogen a very, very strong positive pole, even though this technically isn't an ionic bond. And theoretically, this comparison of electronegativity difference and average electronegativity is a way to calculate the bond characteristics of any compound. So to practice identifying whether a bond is ionic, polar covalent, or non-polar covalent, you can try the practice problems below that simply involves calculating the difference in electronegativity between the two elements and the average electronegativity of those two elements, and see which type of bonding lines up the closest based on the triangle of bonding that you see here.